So, TypeScript, yes. Nice to be at a TypeScript conference. I don't know if you know, I've got a bit of a history way back with TypeScript. I worked on this thing called F#, and it goes way, way, way back. I was there before TypeScript was TypeScript. I was in the Microsoft teams that all fed in towards what ultimately became TypeScript with Anders. A guy called Luke Hoban was program manager on F#. And if you want to dig into my perspective on some of the history about, the privilege of working on a programming language in a very conservative part of the industry. Microsoft ultimately serves, I think the industry divides up into sort of avant-garde and in some ways sort of the more enterprise conservative kind of slower, cautious side of the industry. And Microsoft historically had served that side of the industry. And, but we got to do, they also had this thing called Microsoft Research. We got to do let's take the industry forward. My job was to kind of drag the industry kicking and screaming into the world of strongly typed functional programming. And we won. We absolutely won that battle because every single programming language these days is a strongly typed functional programming language and with strong type inference. And I think there's no better example of that than TypeScript. F# is maybe an exemplar. It's got thousands and thousands of users. TypeScript has probably millions of users. But it's hard to explain, and this paper does explain what a journey that was from the world of what I call the object-oriented tidal wave of the 1990s. Objects were the only thing that mattered. The idea of a function or types or kind of just everything you're used to using in TypeScript that tames the complexity of what you're doing, that was all out of the picture. None of that was allowed. Feature by feature, you can look back through the history about what we were kind of proposing and the arguments and battles and the reactions that we had for year on year, decade on decade. People in the Java world were fighting this battle. I talk about that and the influence that had, and I talk about all the way through. So great fun history, and you guys get to be the beneficiaries of it all in the wonderful system which I've used as well, which is TypeScript, and just the incredible kind of combination of features that they've put together in that system. So if you like one take on the history, dig it out, early history of F#, and would love to talk about that more. But I'm actually here to talk about something very different now, for something completely different. Let's talk about what I like to call the agentic repository revolution. So I work at GitHub Next. GitHub Next, this wonderful team attached to the product group at GitHub. And I absolutely love working in this team, incredible people. Also collaborators across the industry, enterprise customers, also people from Microsoft Research have kind of joined the gang as kind of associate members that are leading members in what we do. So our job is research build, kind of balance, kind of product market fit or platform fit and other things, ship and learn. And all of this is sort of situated in the future of software development, which of course is all about AI for the last few years. It was originated from the team who did Copilot, the original Copilot, the OG Copilot completions in your IDE. GitHub was kind of at the leading edge of the curve, and then the big wave of stuff kind of comes flooding along behind you, and you're there, you've got your completions, you're on your surfboard thinking, hey, we're on the front of the wave, and then you didn't spot the massive tidal wave kind of coming behind, or you did spot it, but agentic AI, task-oriented programming, vibe coding, it's just been a lot of change flooding through the software industry, some of which we saw, but just massive changing time across the industry. And we're living incredible times. All of us are wizards now. You have a meeting and you're chatting about some idea, and then, at the end of the day, boom, they hit the staff and, magicked up the idea. 3 of you have all come up with competing implementations of the idea by the end of the day, and then you've You've got to work out which one you use, and so they absolutely make us magicians. These things can completely blow up in your face as well when you kind of use them, but everything is changing there. So I want to talk about this idea of continuous AI. Now, I think the industry have a blank spot, which is that AI, for various reasons, really originating from the OG Copilot and from the nature of LLMs and from the nature of ChatGPT, it's all about individual productivity. Okay, that is the kind of focus, make the individual more and more productive with AI-based tooling. And coding agents, and that's amazing. They're doing incredible things in that, in chat systems, coding agent-based systems. But something gets lost in that discussion. And it's got to do with sort of inner loop and outer loop kind of things. And we took a step back from that world in around June 2025, and a group of us published this idea of continuous AI, all uses of automated AI to support software collaboration on any platform. And by platform, I really mean a platform that supports continuous development of software. And what we're really doing is taking the mindset of continuous integration and continuous deployment. And we're saying that actually they're just two pillars in the continuous modality, that it's not the end of the story. And that there's actually an entire bucket of a third pillar in the continuous, not a duopoly, it's a triad, which we call continuous AI because it covers a lot of things that aren't covered by the other two buckets. We're not going to mess with your continuous integration and its kind of ethos, or the continuous deployment and its ethos. And deterministic continuous or deployment, for example, is absolutely crucial. But we are going to add a third category, which is continuous AI. And if we're going to do that, we don't mean this as a sort of GitHub term or anything. What we really mean to do is bring together a term for all of the subjective activities that AI actually excels at, and say these things actually, at the end of the day, have to operate inside the continuous modality and possibly sort of in your repo in a lot of ways that align with CI and CD. So if you're going to do continuous documentation, AI-written documentation, you have to do that in the continuous modality because change is absolutely essential to what's kind of going on in your system. That as changes come in, as mergers happen, as reconciliations happen, then a corresponding set of documentation sort of has to be kept up to date. If you're going to do continuous code improvement, that's something you might not just, you can obviously do that with a coding agent today. You can say, okay, fix up all my code according to this kind of thing, make sure every function is documented, every function has a corresponding unit test or something like that. So continuous code improvement, that is code improvement, but you want to put that on a continuous basis. And you don't necessarily want to gate your main line of development on the kind of the continuous application of these kind of principles. Likewise, of course, you can do triage today with a coding agent, just manually, but you actually want it to happen continuously, that as soon as the issues kind of come in, they get labeled, they get summarized, they get responded to or investigated, or whatever kind of happens in your kind of triage kind of pipelines. Likewise, if you're going to do fault analysis, so say you've got a system set up to sort of perceptually sort of have perception over your production kind of system and see faults come up and raise at a repository event. And then you want the LLMs to kind of kick into action, the coding agents to kick into action to do your quality. And of course, there are softer things like weekly reports or research reports, or perhaps there are sort of orthogonal things like looking after that huge backlog of accessibility bugs that your system has, but you don't actually have an accessibility expert, but you're willing to delegate that across to AI for the easy end of the tail of accessibility. So all of these things, automatable, repetitive, these are much more repetitive than what we do with coding agents, and that's got lots of interesting consequences. We can suddenly start to have the system automatically decide which model is best to use for this kind of work. We can start doing kind of metrics over how often are the fixes, what percentage of pull requests get kind of merged. We can sort of We can do prompt kind of optimization or kind of agent description optimization. All sorts of things kind of come from this. And in some sense, these things are event triggered, or there's some kind of system that's saying, hey, now's the time to do it. So you might be asleep and some kind of work is happening in the background, async, without you even kind of triggering it. You just set up the system to, like CI/CD, it just flows. Okay. So that's continuous AI. So that's a conceptual project we did, and I think we nailed it. I think it's a missing part of the discussion about where AI will land. It's like, we all talk about harnesses these days, and I like to think about harness features. So an individual might put together like 10 of features, memory this and coding agent that and so on, to get their harness. And they might sort of agree with the rest of their team on about like 6 of those features, and there's big squabbles over the how to do memory best or something like that. But in the automation space, they might just have like 3 or 4 things they're kind of using, which they all agree on to say, hey, we actually do want to automate a whole bunch of this stuff in our repository. We do want our performance to be kind of continuously assessed and improved every day. And we're going to agree to use these elements of a harness. And in some ways, you can look at what we've done as a automation harness, GitHub Agentic Workflows, as a kind of harness that's specifically, it's part of the GitHub product lineup. It is now in public preview. And it's kind of a great default, trustable, a fairly simple kind of harness that you can do AI automation in your repositories. So GitHub Agentic Workflows, the intelligent automation for GitHub, the coding agents you know and love. So you can, it's running Claude Code, or it's running Copilot CLI on each kind of run. Running in an automated way, in safe sandboxes with containers inside what are already GitHub Actions VMs, ephemeral GitHub Actions VMs, with very strong guardrails in GitHub Actions. And we should, what's an example? I mean, it looks a bit like a YAML GitHub Actions workflow, and that's very deliberate, okay? This is going to be repository automation. You got to check these into your repository. Once you're checked in, there's also a conversion step that happens, but once that, what we call a lock file or hardening, and then it just runs in GitHub Actions with a safe security architecture around the agent. And it looks a bit like a GitHub action. It's got a schedule. It's going to run every week on Monday. You can also do dispatch on them. And then it's got some parts which are a bit less familiar. So you've got triggers. You've got these safe output specs. And this is guardrails. And this is where, because we're running agentic stuff, we know that agentic stuff can you want it strongly guardrails. And this says this workflow is allowed to do one thing, which is create one issue. And that's all. That's all it's allowed to do, one issue. It hasn't got arbitrary write access to issues. It's allowed to create one issue. So that really limits the damage radius of what an agent can do. And of course, there's some tools as well. Okay, so safety is absolutely critical in automation. You know, safety is kind of like in the individual productivity modality. This is where things really begin to differ, because we all turn off all the safety features. It's just YOLO, YOLO, YOLO all the time. No matter what features the organization tell people to use, they just turn it all off, right? Because it gets in the way of individual productivity. Automation is the opposite. The better the train tracks you have, the faster you can run the train. Okay, safety, quality, strength of guardrails is what allows you to go fast in automation. And this is what allows me to sleep at night for this weekly researcher thing, because all it can do is create one issue. So I've no problem with this thing running at like midnight or whatever on a weekend, because it's safe, it's on strong guardrails, it's properly guardrailed. So tools, then you got the prompting, natural language programming. It kind of assumes it's on GitHub, so you can kind of see some nice Actions familiar things here. It's running kind of in the repository on GitHub Actions, so it's able to use the GitHub information model as its kind of ledger. So its output is a GitHub issue. And then sort of self-reporting along the way. So there's, say, an issue triage one, and so on. Dead easy to get going with this. You just install the GHAW extension, and then, say, just add, for instance, a test improver. This will run every day, and it will deliver pull requests which improve the testing in your repository. That's it. You need to have either org-based billing set up, or you need to add a Claude Anthropic API key or a Copilot token for or whatever coding agent you're using. But what could be simpler? It's what I call start your day with code that's better. Okay, what better way to wake up in the morning than to see a bunch of pull requests that improve your project according to your guidance, your control. You decide what the priorities are. You are absolutely in control with what happens. You, the maintainer, are in control with what happens with the automation. Just like GitHub Actions YAML, it's all about empowering the people who run these wonderful sites of production called repositories. I've said safety is super important. You do have to know the basics of the risks of running these things over third-party content flowing into open source repo. You shouldn't give a public project access to private repositories, for example. Lots of basic things, and we try to enforce as much of that as possible, but you should have some basic knowledge of agentic security and the risks of of these things. Okay, so there's some of the security features, and I know we're probably running out of time. I've got a couple more minutes. So once you have agentic workflows, you can go in a couple of directions. You can do lots and lots of different agents in your repository. We've got one repository that has 200 or 300 different kind of agents running. It's what I call Peli's Agent Zoo. And you can look at that. I actually don't tend to do that. I tend to focus on one or two things that you add to your repository. I'm a bit like that with CI/CD as well. I have one CI/CD rather than hundreds of them. So people vary on that thing, but you can find your own zone with that. Say perf engineering. And one thing I particularly valuable, and we're starting to see other people pick up on as well, that is continuous repository maintenance. And let's take a look at this. So this is, I won't give a demo, but I just want to show you Repo Assist here. So Repo Assist is a workflow which kicks in, say you decide how often it kicks in, but the default is every day. And its job is these things, because these things are on an event trigger, they don't have a lot of what I'd call situational awareness. They might know the event, like an issue got triggered or it got woken up once a day, but it needs to take a time to get its bearings in the repository. I don't know if you know the whale from Hitchhiker's Guide to the Galaxy that's sort of born above the planet and it wakes up where am I? Well, I don't know, I've got a tail and things like that. It's a little bit like that. These things get born into the world at midnight or whenever, and the first thing they do is fetch a whole lot of data about the repo to assess what even is the situation in this repository. What's happened recently? Give me a sense. And then actually it just rolls the dice to compute some tasks, depending on what the status of the repository is. If there are lots of new issues, it might choose to go do issue triage. If there's nothing else to do and nothing has come in, it might go and do other things. And then it reads its memory, and then it does, it's got a, let me get rid of that. Not joining that. Then it does a bunch of labeling or commenting or engineering investments or coding improvements or nudging some sale PRs or testing improvements, and then a very generic bucket at the end, take the repo forward. Okay, work out what this software is and work out how we can improve it. And then the end result of that is the outputs of those tasks, which aren't really shown here, are various safe outputs, such as creating a pull request or responding to an issue, taking action in the repository. The human is always in the loop at pull requests. Humans review and merge the pull requests. These pull requests never get merged automatically. You can automatically push to a pull request branch, which you can use to sort of build up a feature commit by commit. But we do not merge pull requests automatically. And then it kind of writes its kind of summary. Okay, so that's kind of Repo Assist. And this thing, it's just a GitHub Agentic Workflow. And if you install this, sorry, that's not the one. What I wanted was this one here. And then this is the definition of the workflow. You can see the default is actually every 12 hours. It's just very declarative. This says you can invoke it using /repo assist in a comment as well. This is where it goes and works out the state of the repo. It lists through some pull requests and so on. And this is tools. These are the different safe outputs about what it's allowed to do. Now, these guardrails are really important. Like, we're allowing it to, for example, update issues. That's actually quite a risky thing to do. You know, that means it's actually going to rewrite an issue body. Okay, but it's got a guardrail here, which says that issue must have a title prefix of Repo Assist, and otherwise it's not allowed to do it. Okay, so we're actually really constraining what this thing can do. We're keeping it safe and keeping it guardrailed in a high-level declarative kind of way, not through some weird kind of MCP tool kind of configuration or something strange like that. Just nice, simple, declarative, upfront kind of guardrails that you can review and that you can trust. Okay, so that's Repo Assist, and then there's a sort of prompting down here. You are Repo Assist, your job is to support this, etc., be polite, and so on. Okay. So, some examples. Try and guess where we started using Repo Assist in this somewhat dormant repository. That, you know, I tried these on a bunch of different F# open source repositories, and you can just see the immediate impact on crunching through the bug debt in this repository. Like, there's not a lot of incoming in this repository, right? None, basically. It's basically a dormant repository. It's widely used, but it wasn't sort of under active development. We're just able to crunch out, I think, 3 major releases, multiple, these open issues included features requests, they included a lot of bug requests. We're able to kind of close that all out with just that, integrating that automation into the repository. Now, doing that with a manual coding agent, I probably could have done it with a manual coding agent, but it would have felt very different. It would have been me kind of asking the agent to kind of work on the bug backlog. Instead, this thing sort of happened automatically at a pace where I didn't have to drive it along. It was just that each day it kind of made a lot of progress on working through the bug backlog. And I actually prefer that kind of working. I don't really want something that I have to drive along. I just want to check in something that helps me get the direction going in the repository. There's another F# repo there. There's a whole bunch of them there. You can read about this in a report we've written called The Impact of Automated Repository Maintenance. And not all repos kind of get the same kind of treatment. Some are on a much slower kind of downward kind of line because there's just a lot more things, or just the maintainer is doing things differently. I didn't maintain all of these. I did some of them. But you can get the general trend that adopting Repo Assist really did make a big difference to a lot of these repos. This is the day of adoption, is the red line here. So what all this kind of adds up to is a point of view that sort of repositories are, you think of them as kind of factories, or they're the site where production happens. Maybe, no, the factory analogy isn't always a good one. Factory analogies are good when it's kind of very repeatable, the items kind of coming through all look kind of similar, maybe burning through a backlog or something like that. But either way, we need places where production actually happens, where things coalesce, which aren't just the individual. That's where places where teams kind of come together to get work done. And there are many options for that. The repository is just a great place. Certainly, obviously good for GitHub because we're very repo-oriented. But it is the place where a large amount of software teams, software comes together and production can happen at that kind of location. I think GitHub have some work to do. Sometimes you have multi-repository setups, for example, and they together should form a site of production. Okay, you shouldn't have to kind of So we have work to do on auth in, say, multi-repository scenarios. Organizations can form also a kind of overly large site of production, and so but really you should be able to kind of move fluidly between these kind of different sites of production. And of course, it's possible that there are some built-in things in the factory, and there are also external things working. GitHub is an open platform where external kind of input can happen into these kind of sites of production as well. We've written this up as sort of this kind of SIG plan thing. Repositories are human agent knowledge factories, kind of similar kind of theme, if you want to dig into that. Once you have a factory kind of thinking, you can start to use factory flow kind of thinking, and it's sort of analyzing how things flow, how work items kind of flow through the factory floor, and the different possibilities that kind of might happen. And that lets you identify, actually, this factory is kind of flowing, these factories are kind of idle, and these ones are actually kind of blocked, right? The maintainer is probably usually blocked on human kind of factors. I do want to emphasize that's okay. Like, humans come first in this world, right? It's like if the humans have decided that they're not engaging, actually they're on vacation, or they've got other priorities, or it's just like they only want to engage every month or two on maintenance, totally fine. It's okay for a human. It shouldn't really even be called blocked. It's sort of just like waiting, or like waiting for human input. So in some sense, you can say you're now a factory designer, as well as being a harness designer and a skill designer and everything else you have to be these days. But it might be that you have to think about these sort of automation a lot more than you previously did for a lot broader set of tasks in your team than you might previously have done. And your job is to avoid this, which does happen and is happening all over the industry. One of the problems with the individual productivity point of view is that, like, this guy here kind of works to get the logs flowing on part of the log jam, and he says, look at me, I'm using my agent, they're all kind of flowing. I got 50, I got 100 past my point today. And of course, you're just creating more problems downstream rather than getting the whole thing flowing together. Okay, and that is real. Okay, and again, it's that try to get that point of view on the collaboration to unjam the log jam and to actually get things flowing down the river. Okay, we're using this internally at GitHub. I'm the factory runner on N+1 Query Crusher factory on the GitHub service implementations themselves. Also running a factory called CI Perf Improver, which relentlessly, day in, day out, tries to find ways to improve the CI Perf on the GitHub engineering side of things as well internally. And just to finish up with sort of all points to kind of new, that there's automation has historically allowed us to do all sorts of work that wasn't being done before. The car led to travel that wasn't being done before. The factory eventually led to quality products that weren't being produced before. Medicine led to diseases that weren't being treated before. So actually, there are a lot of things in computing which should have been done all the way along, but we were never able to put on a sustainable basis. Performance engineering is my favorite one. Site reliability engineering is another one. That in performance engineering, there have been a lot of heroic people over the years who have kind of gone into kind of, say, the .NET runtime or the JVM or into Linux and kind of done their performance work, but they never got it on a sustained basis. They kind of left their scripts lying around and their benchmarks, and nobody really runs them and so on. And so with automation and with agentic working, we can put a lot of parts of technical work onto a sustained basis and ending up with overall higher quality in our repositories, kind of not lower. And I think this is a bit of a counter to the kind of AI slop kind of narratives that if we set the agents following and pursuing quality goals in automated, measurable ways, then we're going to land in a good place. Okay, and that's it for me. thank you very much for having me at the TypeScript.